Hello.
Hello. How's it going?
Going good.
Good,
How are you?
good. Happy Friday. Hello, Nanas. How are you?
Good, how are you?
Good. Did you ever get that email? Lesson 13 test?
Yeah, I will send it today.
Okay. And you can send because I graded yesterday's test as well. You can send that one at the same time.
Sure.
Thank you. Hi, Maimona. Wow, Maimona's excited to be here. Lenov, if you could do that kind of excitement move, that'd be great. Ready, go. That's perfect. Thank you, Lenov, for that energy. Man, Lenov really brings the energy. It's good. All right.
He's not here.
Mia, I heard, is not here. Who said that was okay? Who told her that was fine? It wasn't me. Okay, we're gonna jump right in to lesson 16. Are you ready? You can take your notes out or however you like to keep track of stuff, probably in your notebook. This is the surface area of solids. We just did volume of solids. So basically the same shapes, rectangular prisms, pyramids, cylinders. I don't think we do spheres because spheres, surface area, I don't know, we just don't do it. Well, not in this class anyway. It's okay, you don't have to feel left out. If you want to do surface area of spheres someday when you're studying to be a mathematician, do it. I want you to do it, but not today. Okay. So what is surface area? Hey, Mona, do you want to tell us what surface area is?
It's the area of the surface.
Oh, I knew you'd come up with a good answer. Good job, Maimona. It's the area. Let's just do that. I mean, it just doesn't get any better than that. She took the phrase surface area and she rearranged the words. Okay. Now, that might not be very helpful to some of us, but it's pretty profound. So, good job, Maimona. The area of the surface. Yes, Naros, I appreciate that little quip. It is a very surface level explanation. Oh my gosh, we got mathematicians, we got comedians. What else do we got today? Whew, Lenov's really excited to be here, dancing all over the place like Maimona usually does. I mean, Kel, what are you bringing to the table? Come on.
I don't know what can I bring to the
Well,
table?
that's what I need. I need you to do something. You're gonna have to contribute in some way, shape, or form. So far, we've had comedic effect from Naras. We've had profound statements of rearranging sentences from Maimona, and we've had unbelievable enthusiasm from Lenov. And Mia decided her contribution is going to be not to show up. So you got to do something, Kale.
Oh
I
my
mean,
days.
oh my, there it is. He just brought Jonah into the classroom. Well done. I didn't see it coming, I'll be honest. I did not see that coming. That is wow. Wow. Hey, am I wrong or did Lenov just go black and white? It almost looks like Lenov is black and white. Nope, he's definitely blue. Never mind. False alarm. Never mind, don't worry, everyone. Lenov is no longer monochrome. That would be pretty brutal. Okay, I'm gonna give a slightly different definition of surface area. I want you to write this down, even though Maimonas is pretty great. I'm not denying that Maimonas is great. I just also want you to think about this. Okay, it is the combined, I'm putting it in the chat, the combined area of the outside surfaces of a three-dimensional shape. And then I'm going to put IE. Ever see that? IE? You know what that stands for? I'm going to put like unfolding a cardboard box. Now, let's pretend example 1 is a cardboard box. Can everyone picture it? We've got a cardboard box. So the outside surfaces, how many outside surfaces do we have in example 1? So if you haven't already, draw your little example 1, draw a little box somewhere. And if it helps, you can color in your box. Some people gain a lot of, it just helps them motivate them if they color stuff. So let's say I colored the top red. What are the dimensions of that top? Maimona?
2 times 5. 2,
2 by
2,
5.
5. Yeah.
2 feet by 5 feet. That's the top. Great. Is there a bottom? Does the bottom of the box exist? We can't see it. Kale says yes. The bottom is also 2 feet by 5 feet. All right. So we got 2 surfaces taken care of. How about the purple side? We'll just go stripy purple. Nas, what are the dimensions of the stripy side?
Sorry, what?
What are the dimensions of this blue or this purple stripy side over here?
2, the 5 and the 3.
Yes. So how would we find the area of all this purple? We would multiply what and what?
5 times 3.
Simple. 5 feet times 3 feet. Lenov says, but there's another side over here. And I agree. 5 feet by 3 feet. Lenov will not be fooled. Okay, so we got a top and a bottom. We got side 1 and side 2. What is remaining, Kale?
Right there.
Oh,
The point towards us. It's looking at us. The green
What-
part.
what would we call that? The front?
The front, sure.
All right. So we got a front. And what are the dimensions on the front, Kale?
They are 2 by 3.
2 feet by
Feet.
3 feet. And then back here we got the back, which also is 2 feet by 3 feet. So we notice very quickly that there are actually 6 sides here that we're going to have to consider. If we're going to combine the area of the outside surfaces, there are 6 outside surfaces in this cardboard box. Now, here is another way to consider the same thing. I'm going to show you what it would look like if we unfolded this box. Bum, bum, bum. Wow, look at that. It's like the box got unfolded. Now, let's see if we can color these the appropriate colors. Um, here's my 2x3. That's one of my 2x3s. Here's another one. There's the front and the back. Some people can see this right away. Some people can see the unfolding of the three-dimensional box right away. Other people, it takes a bit. That's the front and back. Uh, what else do we got here? Let's see if we can. My pencil's not working. There we go. Maybe. The top. Where's the top? The top and the bottom. Well, they're 2x5, so they ought to be 10s, right? Maimona said they ought to be 10s. Oh my gosh. Whoever touches that, it goes away. I'm not sure why. There's the 10s, the top and the bottom. And then that leaves us simply with the purple sides. Everybody likes purple. Wait, is that true? Does everyone like purple? Okay, I got a few head nods. That'll work. All right, so there's our purple sides. So if we unfold the thing, we see that this is now it's a two-dimensional shape, which we can add up all the areas for. So just like we had 5x3, we know that that's 15. Over here, 5x3 is 15. So we're adding those. We're adding the 2x5 to get 10. And the 2x5 over here to get 10. And we're adding the 2x3 to get 6 each time. So the picture shows the 6. That's the area. It shows the 15 area. And it shows the 10. So we're just going to add them all up. It's the combined area. So 15 plus 15 plus 10 plus 10
66.
plus 6 plus 6, 30 plus another
62.
20 is 50 plus another 12, 62. And should this be cubed, squared, feet, what?
Square.
Square.
Feet squared. This is area. So last section we were doing volume, we need feet cubed, but this is area. All right. Everyone go onto the whiteboard in your own little area and see if you can draw what this prism in example 2 might look like. If we unfolded the prism in example 2, go ahead and get onto the whiteboard.
Is that not just a pyramid?
It is a pyramid, but I want you to tell me what it looks like when you unfold it.
Okay.
Whoa, someone's going to town already. Once you've unfolded it, go ahead and write the dimensions on there. Ooh, Lena went with the built-in shapes. I like it. The one over here on the left looks kind of like a flower. That's pretty. Now, Naras, it looks like yours has whose has a triangle in the middle here? We want to be careful about this middle.
That's me.
So how do we know what's going on here? I guess I didn't specify. This is a pyramid with a square base, not a triangular base. So the thing on the middle of our picture should be a square. I want to be clear on that. Lenov, it looks like he's got a square, or at least a rectangular looking thing that he's trying to make sure is equal on all sides. He's got some triangles that he's rotating and flipping around for fun. Maimona has a lot of writing all together. It's exciting. Pretty exciting stuff, Maimona. Okay, good job, Lenov. He's got his system all worked out. What's Kale doing over here? Oh, Kale is wow. Kale is creating a XY coordinate plane. And he's bringing the Jonah vibe. Oh, his days. I'm not sure what Kale's doing, but it's gonna be fun. Ooh.
Mr. Dan,
Yeah.
in example 3,
Yes.
by the way, did you remember when I tried to show the Dutch math problem? It looks very similar to example 3.
Oh, really?
Yeah.
What were they asking in the Dutch math problem? I forget.
Um, let's see if I can find it.
Yeah, go ahead if you wow. Man, you're really going for it. There are no mm, mints. There's no mints.
Unit. There's no unit.
It's really sad when no one brings mints to class. I agree. It's tough. I mean, sometimes people have bad
Yeah.
breath.
Why are there no units though?
That's a
So
great
sad.
question. It is pretty sad. I
Yeah.
didn't notice the lack of units. Example one has units.
I
Example
have
three
the
has units.
answer,
All right. Ramona has the
I
answer.
think, but I don't have units. So I just
Oh, I
did
see.
squared, nothing.
Squared, you could just say squared units. If they don't tell you.
Oh, got it.
Okay, I'm gonna throw together my drawing real quick. Now, I'm technically cheating here, but I don't want to brag or anything, but I think my drawing's pretty great. Look at that. Boom. I mean, it's pretty close to Lenov's, let's be honest. Lenov and my drawings are pretty close. Okay. So we got to be careful about our sixes. Six is the what? What would we call that based on last lesson? Is that the altitude? Is that the
Wait,
height? The surface height? Slant height. Good job. But the slant height ends up being, in our little diagram, it ends up being the perpendicular height to the base of each of these triangles. So each triangle has an area of 1/2 base times height. And that means there's 1/2 times 5 times 6. So Maimona said that every one of those triangles has an area of what, Maimona?
I don't know why it gave me 47
What gave
point.
47?
Wait, maybe it didn't. I don't know. I think I did that.
Did you use a calculator, Maimona?
I did.
Yeah, that's gonna hurt you in the long run. Because when you use a
Uh,
calculator for simple things that you don't need a calculator for,
yeah, Now that
Then it
I'm
gives you
thinking
a
about
weird
it, it
number.
should have been 15.
Interesting.
So it's not right.
Yeah. So she got 15 here, squared units. And she thought, well, there's 4 triangles. So 4 times 15 is how many square units? Anybody? 4 times 15? You guys are very focused.
60.
Yeah, it's 60.
So then you add 25 from the
And then
middle.
25 is in the middle. So she's going to add 25.
85.
There we go. As opposed to 213.4, which is another commonly missed answer. I don't know how you got 234. Maybe I really don't.
It's because when I did this stuff, it gave me 47.1.
Yeah. So where's
Yeah.
what I need is a little red flag to go off in your brain when that happens. Like
Oh,
kind of like a warning light, like, hello, this is not good. Something went wrong.
maybe. Yeah.
All right. Kale is still working on his masterpiece. Wow, Kale, that's impressive. He's even got the little boxes there with the right angles. Okay. Now, it looks like Naras has shown us essentially what this cylinder is going to look like when it's unfolded. And I
That's
can
true.
see in my study of Dutch, it's clearly asking for us to calculate the circumference of one of the circles. And,
You're very good at Dutch.
oh, thank you, thank you. Round to 2 decimals. Is that saying that twee is 2?
True.
Wow. See how I did that? I just learned a number in Dutch. Now, the next part is asking for the length of the rectangle, or it's telling us the length of the rectangle, maybe. All right. This is helpful. Thank you for this, Naras. So what we're going to do is we're going to follow these steps. What does it mean a rash is drawn? What does that mean?
Yeah, I tried to find a translation on Google Translate. It said rash, but
Huh.
I think a different way to describe it is just I don't know, like a drawing
Like a
or like
model
the
or drawing,
yeah
yeah.
the two-dimensional model of the
Yeah.
cylinder.
Okay. Very good. Okay. So Kale, take a look at Naras's part A. Why do you think it's important to do what part A is telling us?
Uh, I think that we need to calculate the circumference because once we do that, then we can multiply it times the height of it, and we can get the entire VL square right there.
Okay. So Kale is saying that the circumference of the circle, define circumference for me again, Lenov. Could you tell me what circumference is?
It's like the full length around the circle.
Okay. So Kale's telling us that the circumference of the circle, or the full length around the circle, is the same as the length of the rectangle. Is that what you're saying, Kale? That sound right? Calathon. So this little distance right here, the distance around the circle, Kale is saying is exactly the same as this length right here. Now we saw that, hopefully we saw that with our wheel. Remember our wheel? We made a little wheel. And the wheel rotated and made a line. And we loved our little road, I'm sure. So it's important to do part A. of, as Naras's question is kind of laying out for us. Because once we do part A, we have the length of that rectangle, and we can multiply, like Kale said, by the height of that rectangle. Whoops, I wanted to be a different color. Length times height. And then are we going to use the circumference for this? How do we find the surface area of the top and the bottom? What's the area of a circle? Is it the same as the circumference of the circle? Wait. Maymona, are you telling me we're going to have to find the area and the circumference of the circle? Oh my gosh. All right. Here we go. Let's go up to our example right up here. Let's take our little drawing and let's see if we can come up with our own little drawing of what this thing looks like. Mine looks like this. And I've got a radius of 3. And I've got a height of 10. So does Maymona, as it turns out. What's the circumference? How do I find circumference, Kale?
For circumference, to simplify things, instead of doing 2 times pi times the radius, you can just do pi times the diameter.
All right.
So it would be 6 all the way across, 6 times pi.
Okay. What is that, Maymona? That's 6 times pi? And what would the units be on that in this problem? 18.84 what?
Inches squared. I mean, not squared.
Just inches. Okay. Very good. So now I know that the distance on this rectangle is 18.84 inches. So I did part A of Naras's process. Part B says the length of the rectangle is equal to the circumference. So that's good. We now have that length of the rectangle. Now we can find the area of the rectangle. What is the area of the rectangle?
I'm getting confused with the numbers that you're using.
Go ahead. Which part?
Are you doing example 3 or are you doing my example?
I'm doing example 3. I'm using your steps though, kind of.
Oh, I see. Okay.
So I basically we did part A of your process. Now I'm
Uh-huh.
gonna do part B, which is calculate the area of the rectangle. So Maimona is very patiently holding up her calculator because everything your calculator says is right because it's a calculator. And what would the units be on that, Lenov, since Maimona's calculator doesn't give us units? 188.4 what?
Inches squared.
Inches squared. And then part C, Naras, could you read us in Dutch? Because I think we need to be a little bit more educated than just English.
That's true. Oké. Bereken de oppervlakte van een cirkel rond af op 1 decimaal.
Ah, yes, of course.
In other words, calculate the surface area of the circle, round to 1 decimal.
All right, surface area of the circle. Kale, what are we gonna do?
With the area of the circle, and we already have the circumference, right?
Mm-hmm.
So are we supposed to take the circumference, multiply it times the height now?
Well, to find the area of the circle, I don't need to do that. How do we find the area of any circle?
Oh, I thought we already we do pi times r squared.
Very good. Maimona is our calculator. So she's going to tell us in a moment what the
Sir, I have
area.
a question.
Yeah, go ahead.
Is it called area or called surface area?
Well, overall, that's a good question. Overall, we're looking for the surface area of this whole cylinder, right?
Yeah.
But when we create this shape or this shape, depending on which one you use, when we roll it out basically and flatten it, then we just refer to it as an area of the shapes that show up. So it's both. The answer is both. I'm looking for
Okay.
the surface area of this cylinder, the outside edge of this cylinder, but in order to find that, I'm going to flatten it out to discover what shapes I actually need to find. So I know I have two circles and a rectangle, and I have to find the area of those two circles and that rectangle. Does that make sense?
Yeah, it does.
So Maimona is telling us that 9 times 3.14 is 28.26. Is that what you're saying, Maimona? I'm not going to lie to you, that seems a little low, but I'm going to have to trust you for now. No, I lied. I'm not going to trust you. I'm just going to try it myself. And you are correct. Well done. So the area of the circle is 28.26. How many circles do I have? There's two. So I'm going to multiply this by 2. And Maimona has that on the calculator, I'm sure. So she's ready with her answer. 56. Oops, sorry. 0.52 square inches. Thank you, Maimona. Now back to that's basically part D. Well, part D is saying put all this together. So it says calculate the surface area of 2 circles and the rectangle combined. So I want the 2 circles plus the 188.4. Is that right? That's the rectangle. And one rectangle. And look at that. We have another example of Maimona with the calculator. 188.4. And she got what I got, 244.92 square inches represents the surface area of this cylindrical solid. Now, Naras's instructions say round your answer in full centimeters squared. Ours is, in fact, to 2 decimal places. If we wanted to round our answer to full inches squared, we would say 245. That's the nearest full inches squared. But I think we can leave a decimal in there and be okay with that as well. Very good. Bravo, Alik, everyone. All right, next up, why don't we take out who's going to get the worksheets if Mia's not here? Lenov is the backup Mia. Go, Lenov. Thank you, Lenov. Let's try 16 A and B. Maimona, tell him A and B.
I feel
He
like the biggest
said no
difference.
problem.
That's amazing. What was that, Naras?
I feel like the biggest difference between like the worksheets that we're doing here and like the math I did a few years back is probably like the fact it was like step by step, and in the worksheets it's just give one answer kind of thing.
Yeah. Yeah. No, I like how the problem you shared with us, I like how they just walked you through step by step, like you said. I think that's very effective.
Mm-hmm.
And when you're first learning it, that's super important. And hopefully at this point we can kind of combine those steps even if we're not told what they are. But it's good. Good to start with that process. Which internet are you all using right now? The 6-7 internet?
Mr. Answer.
Mr. Dan two.
We should name an internet 6-7. That'd be
No.
actually crazy.
It's fine the way it is, Maimona.
That'd be
There's
so
enough.
awesome, though.
I know, but there's enough
Awesome.
6-7 in the world, maybe too much, let's be honest.
No.
You would think as a math teacher I'd be excited about a trend that's about numbers, but I'm really not. All right, let off. You did a great job. Thank you.
I haven't heard you say it.
Wait, what?
I told him A and B, but he only heard A, so we only
Oh.
have A. But now he's getting B, so it's all okay.
All right. All right, so if you could wrap those up for homework over the weekend, that'd be great. You want to start right now? Let's crank through a couple or what? Okay, well done. Look at that board. If you zoom out and look at the whole board, it's pretty impressive. It looks like a lot of work. Good job, everyone. We did it.
So colorful.
Yes, it's very colorful. Oh boy. Lesson 17, we're moving on to crazy things. So be thankful for shapes while they last. Dun dun dun. Because lesson 17 is not about shapes.
We're gonna go from 6 to 17.
Have you ever done it with your hands this way?
No.
That's 40.
You should try.
Mr. Ram,
Yes, sir.
what do they mean, the lateral side of a cylinder?
I guess, can you read the whole thing?
Question says, in order to find the area of a lateral side of a cylinder, multiply the blank by the blank of the base.
Oh, the area of the lateral side of the cylinder, you should multiply the height by the circumference of the base.
But what do they mean with the lateral side of a
Yeah.
cylinder? Like, how does that look like?
Basically, if we draw our picture again, there's only three sides. Think about it this way. There's really only three sides. So I'm over here on the left. There's
Yeah.
only three sides to a cylinder. There's a top, a bottom, and then a side that goes all the way around. This is the lateral side. And so
Oh.
the two blanks they're asking about are if you're going to find the area of this rectangle, you're going to have to multiply the height, right? This is the height. You're going to have to multiply the height by the circumference of the circle, or what they said is the blank of the base. But because the base is a circle, we have to multiply by the circumference of that circle. Because the
So
circumference of that circle is the length of the lateral side.
so is this like the longitudinal side then?
Um, well, when they say side, I think what they probably should have said is the lateral face, maybe, Like
Oh.
they're actually talking about the edge all the way around the cylinder, the edge of the can or where the can would have its side.
Okay, I got it.
Yeah. Hey, Mona, did you still want to hear about lateral or did my explanation to Nas help?
I'm still confused.
Okay, do you see my drawing over here?
Yeah.
Over here. So when they say what is the lateral?
Come in somewhere else.
Wait, who? Huh?
It talks at the door. Ooh.
Yeah, I think it's time.
Oh, it's time. It's overtime. Sorry, guys.
What about lateral?
The lateral side right here in this part right here. See this? The lateral
Just the
side,
circle?
the lateral side is not the circle. The lateral side is the rectangle.
Oh,
So they
so
want
like the
they're asking how do you find the length and width of that rectangle?
so lateral is just the thing around it. Like that's the top or the bottom.
Correct.
Okay. Thank you.
See ya. Bye.